In this problem, we're given the resistivity of a material and the radius of the wire that this material produces, and we're given its length. And we want to know what is the resistance. So the resistance of a wire depends on the resistivity, what that wire is made out of, times its length. The longer the wire, the greater the resistance, but divided by the area of the wire. The wider, the thicker the wire is, the less resistance it's going to have. So this wire is really just a long cylinder. And so to calculate its area, really we're going to do, the pi r squared, because we're just looking for the circle that makes the end of this wire. What is the area of that circle, that part of the cylinder? So pi r squared. So we have our resistivity, we have our resistivity, we have our radius, and we have our length. So we can solve for the resistance itself. So the resistivity is 2.79 times 10 to the negative 8 ohms times meters, times the length of this wire, 52.6 meters, and then divided by pi times the radius squared. So 2.46 times 10 to the negative 3 meters that we're going to square. And if we look then up here, we're going to have meters times the meters, and then we're going to end up with meters squared in the denominator. So those are all going to cancel out. We're going to end up with ohms for resistance. So 2.79 times 10 to the negative 8 times 52.6 divided by pi times 2.46 times 10 to the negative 3 squared. And we get a resistance of 0.077 ohms.